Hello, I'm John Clifton. I'm a product manager at Sonar. Now, AI has been part of our lives as developers for a very long time. It's been suggesting fixes, it's been helping you refactor, it's been completing functions for you. But more than ever, it's becoming a larger part of our life, but as an autonomous developer. More and more now we can delegate work to agents and leave them running for minutes, hours, even days. And this is becoming exciting, but at the same time, how do you really see the benefits? As an enterprise, you can't just ship these things that are coming out the door. They need to be verified. They need to be proven to be production grade. This is a big problem. But luckily, I've got two people who can talk to us about how we can address this. I'm very pleased to welcome VB, who leads developer experience and community initiatives for Codex and EMEA. He's been instrumental in bringing GPT 5.3 Codex, Codex App, and Codex Spark to millions of developers across the globe. Prior to OpenAI, he led developer experience at Hugging Face. And joining us is Tom Howlett. He's the product director for code quality at Sonar. His team is responsible for developing Sonar's analysis engine and bringing that into the agentic workflow. This represents the deterministic bedrock that provides the ground truth, enabling agents to verify their own work. So let's get started. Now, OpenAI with Codex is helping us build these agentic workflows. But even more than that, OpenAI is one of these enterprises that is having to build in this agentic world. So the big question to start with is, how on earth are you doing it? How are you getting to production with this technology?
I'm glad you asked that question. To be honest, it's really hard to imagine OpenAI functioning at the speed as it does and shipping features at the speed of practically like at this point without having Codex deeply ingrained in its developer workflows, even product designers, PMs, and like everyone has their own workflows around Codex, the app, IDE, CLI, and so on and so forth. And there are some quite interesting ways in which people use it. First of all the code within OpenAI, 100% is reviewed by Codex, right? All pull requests are reviewed by Codex. None of the pull requests are merged without a review. Second of all, majority of the code written by the developers is assisted by Codex, either with the Codex app or with the Codex CLI or with the Codex IDE extension within like Cursor, VS Code, and so on and so forth. At the same point, Codex has been quite instrumental for the research team itself to help build Codex 5.3, which is the recent model that we just released, wherein Codex acted as like an on-call support agent, not only babysitting training runs, but also trying to find config mismatches, trying to figure out where things might go wrong, and alert team where it thought that it needed the support from the team itself. Last but not the least, like one of the things that still amazes me is that product designers use Codex with Figma to create nice UIs, nice sort of assets, and then again use Codex to convert these assets into actual code. And last but not the least, one of the examples that I wanted to share was someone from my team, Brent, who is a video producer. He recently used Codex to edit videos. And the way he did that was by literally asking Codex, here are some video snippets, and I want it to be synced to certain specific transcript, or I want you to create like YouTube shorts out of this, or Instagram shorts out of this, and so on and so forth. And what Codex ended up doing was literally creating a bridge between Codex and Adobe Premiere Pro, and then using that to create out different segments of videos, also proactively suggesting where to cut, what kind of snippets are interesting, and so on and so forth. And this led to all the videos that you saw on OpenAI for developers for the Codex app were like leveraged Codex and this bridge.
Can I just jump in? Because you said about Codex reviewing the code.
Yeah.
Is there also human review? Is there any other review as well on top of the Codex doing review?
Right. Of course, there are like varying criticalities of code, right? Code that is shipped directly on devices or on the web. All of those do get like a human review as well, just to make sure that none of the nothing is missed. Because of lack of context for the agent, or just generally to make sure that the code being merged has like meets the quality that we expect. At the same time, there are some non-critical areas. For example, I like to use Codex to try out different skills or to try out different automations. In those cases, I would just trust Codex and its review that it works the way it does, right? And of course, like when we push things to production, we want to make sure that it meets the quality bar. And of course, in those cases, we would leverage a steady suite of test cases or and also just like human intuition and so on.
Okay, so you're really kind of changing the process depending on the risk profile of the application that
Definitely, yeah.
putting out. Yeah, that makes sense. Cool.
And can I ask you, so you talked about how, I mean, different people seem to have really creative ways of using Codex. How do the teams share those ideas so that everybody's learning from each other?
That's a very good question. So we have this channel within Slack. It's called Codex Hot Tips, and it's brimming with like developer excitement. There are people who are sharing how they're using Codex with Slack. For example, I use Slack via Codex quite a bit, right? I use it to prepare my morning briefing of like, all right, these are the channels that I want to look at. Here is a summary of what has happened in the past 24 hours. Especially, this is quite important given that we're a globally distributed team. I'm based in Paris, and rest of my team is based in the US. Some are based in Singapore, and so on. So Codex helps me in this case to sort of give me like a summary. At the same time, people are doing all sorts of novel things. For example, someone yesterday posted about a PR, which is PR review skill, which is actually part of the open source Codex GitHub repo. It's called Babysit PRs. And what it does is, as and when your PR is open, it would continue polling the PR to check if there are any issues.
Okay.
And if there are any issues, it would flag it to the end user itself. And of course, in most cases, it would just see the issue and it would fix that issue, and you don't even have to worry about. But in some cases, maybe it's missing some sort of an access token and so on. So this is where the agent proactively tells you what to do, right? And this extends across like all of our CI systems as well. Wherein, for example, whenever I'm pushing something to our production code base, and like the CI is complaining, I honestly cannot be bothered to like look at the logs and like, why is this not working? What should I do? And so on. So I have a skill in this case which would just look at the CI logs and would just fix it, right? And so far it has not let me down.
Wow. Yeah. That's just so much making the life of the developer easier. Right?
Yeah,
So those
exactly.
painful bits that slow you down.
Yeah.
Nice.
And I think, that's one of the things we ran a survey recently, and I think the number was 96% of developers don't trust the code that they own. It's being produced by AI, but they're responsible for it. How, I understand that you've got sort of different levels of checking in place. How do we go about helping our developers be confident that the thing they're going to get called up at 3 o'clock in the morning about is going to be good enough that they can sleep soundly?
So, I mean, I guess from our perspective at Sonar, right, the Codex is producing some amazing code. It's really high quality, but you never quite know what you're going to get, right? You need to verify, and you need to verify deterministically. And we were talking a bit earlier about this, about how you have these checks that Codex must do to ensure that it's correct. So at Sonar, we've been doing static analysis for a long time. We've been verifying code deterministically to make sure it hasn't got certain bugs, or it's maintainable, or it's secure. So we can do that same thing now with Codex, right? So by using our MCP, the MCP can call out to the Codex can call out to Sonar and say, are there any issues on my code, in the same way? And I think these checks are absolutely key, and they have to be deterministic. And the more deterministic checks you can do, the safer that code is, the more we can build confidence with the developers, and the less work they have to do in verifying the code themselves, right? Because if they're verifying every line of production code in the enterprise, it's going to slow us down so much. We're not going to see the benefits from AI. So we need to do as much as we possibly can for the developer to make that efficient and really see the gains that we expect from AI.
And I think like determinism here is kind of the key, right? Like, because I see this all the time, like every time, especially for like open source projects like Codex itself, if something is not working, one of the key things is the ability to reproduce the reason why it's not working, right? And if you have these deterministic tests, it just makes it so much more easier to find the root cause of a problem, right? Like oftentimes we would see engineering teams, not just within OpenAI, like across the globe, complaining that, hey, like I have this flaky test within my CI, and like, you just you cannot really do anything except just like rerun the CI and hope that the flaky test pass, right? And I think this is where sort of tools like Sonar come in and sort of like help you with the deterministic tests that just work.
Yeah, it's all about giving the agent as much data as possible, right? And whether that's from logs or whether it's from other checks coming through, then we can really enable the agents to do a good job. I think we kind of expect the agent to be perfect, kind of running blind, right? Which isn't realistic, is it? It needs to have visibility of all these things, and this is stuff that we would run anyway. And so let's give the agent the same visibility that the developer had in the first place. But it can process it so much faster. That's the beauty. That's the addictive nature of this stuff.
Well, that's the thing, isn't it? So how do you balance, you want to go as fast as possible. You want to give your teams the autonomy to try out crazy stuff, because the sort of the ability to deliver quickly and at high quality is a competitive advantage now. How do you balance letting people go fast, try things, break stuff, with the real needs of real companies, which is like, this thing has to be good enough to go into production? How do you have that sort of almost double standard?
Yeah, I think it's like, so like a quick anecdote from some of the things that I was doing quite recently is we released the Codex app, right? And it's been widely acclaimed, and a lot of developers are using it today. And part of this Codex app, we released maybe 15, 20 set of curated skills, which users can use to then augment what they do with Codex as of today, right? And so these skills are something like, how do you connect with Figma? How do you take a screenshot? How do you control a browser? And or like, how do you interact with GitHub? And so on and so forth. But then again, like these skills itself, you cannot just prompt an agent to create a skill, right? You need like some sort of a clear way to test these skills out in a way that you have like a full coverage of not just user systems, platforms, and also just like different edge cases that you might face, right? And so as part of that sort of trial and error and like coming up with these skills and like how they work and so on, what I ended up doing was like prompting Codex to create like a suite of test cases. And these test cases would essentially be would try and like sort of prompt the skill in different ways, right? And try and see whether it gives like a deterministic output that I expected, right? And then it would just run this on a CI and like continue, like every time I would make a change to the skill, it would continue running these test cases. And so this way we effectively ran like evaluation for all of these skills, right? And hence we were sure that these skills would work across different systems, different user profiles for different needs, and so on and so forth.
Oh, that's great. So actually, you've got tests around your tooling to make sure your tooling is working. Then you give that to the agent.
Yes.
Yeah, that's fantastic. But you're using the agent to do the test for the tooling too. So that's perfect. Yeah, I need to do that with the skills I've been using.
I mean, that's what I was going to ask, actually. I mean, it's really two things. So you talked about connecting to different skills. I think one of the things that's becoming more and more frightening is how much power an agent has to do so many different things. But at the same time, do you want to give it all that freedom to go on a rampage? How do you recommend, or how does Codex help people run in a safe environment and still move fast with agents?
Look, the demand for Codex is insatiable at this point, right? Like since the start of the year, we have triple the amount of developers building on Codex, right, across different surfaces, the app, CLI, IDE extension, and so on and so forth, right? Which essentially means that people want to build, right? People just want to build, and they want to, try and experiment things. We're literally limited by creativity at this point, right? And at the same point, this sort of throws the liability of making sure what Codex produces and the way it produces onto the harness itself, right? And the way we do it is by providing a few options to the developer itself. For example, we have a nice sandbox, and you can set your network rules. For example, if you want Codex to use web search, you can allow it to use web search. If you think it's not safe enough for it to use web search, then you can just disallow Codex to use it. You can also define rules for what kind of CLI commands or what kind of bash commands is it allowed to run. Is Codex allowed to commit on your behalf? Is Codex allowed to open a pull request on your behalf? Or is Codex allowed to RF on your behalf or not, right? At the same time, you can decide whether Codex has the ability to write, or does it only have the ability to read, right? And not just that, like you can, if you're an enterprise, you can sort of like set up these granular settings for your entire company or for developers who are using within your company on what's allowed and what's not allowed as well.
That's great. I mean, one of the questions that's always very interesting is how much of the responsibility of making good choices is on me as a developer versus how much is it on Codex to help us make good choices or give us guardrails to work inside. And that's, is that something we can talk about, what sort of how Sonar plays in that?
Yeah, I mean, even beyond social, I think you have to start with the organization, right? So if you're developing code with Codex, it needs to be at the same standard. It needs to be secure, reliable, maintainable as it was when humans were developing it. The hope is that we can do it much, much faster. So you need to put all of those same constraints, all of those same checks and verifications that you had before with human developers and somehow replicate that in an agent environment that can help us increase productivity. That's the actual thing. So I think, with organizations that I'm talking to, they want to apply the same policies they always had. They don't want to make any compromises for this speed, and they can't, right? They've still got the same risk with the applications that they launch. So it's perfect that you give that granularity of control, and it's a lot of onus on the organization to make sure that they're putting the same control in, but enabling their developers to go faster. Now, Sonar, we're making sure we're building our tools so they can interact directly with the agent, and that enables the agent to do that work and not have to have a human in the loop all the time. I think that's the key, right? The more we can enable the agent, the better. But absolutely, the standards shouldn't be compromised. But we want to unleash this amazing capability. And so it's really a matter of tooling, I think, more than anything else. But also good policies in the same sense, and not compromising on the policies, but how can we apply those policies in this new world?
And I guess to some extent that it's not, when we talk about developers here, we don't necessarily mean proper professional developers that have been developing, I was going to say 24 hours a day. 24 hours a day, let's not get into that. But the idea is it's now other people developers. You've got people like me. So I used to be a developer in the distant past, and I want to get back into it again. And it's one of those things where I won't necessarily know about SQL injection. I won't necessarily know about cross-site scripting problems. And the onus, or it becomes even more important to have guardrails that will be applied and that will make sense, even for someone who has good intentions, but probably doesn't have the background to be totally rock solid. And how does that work from a Codex point of view? Who are you designing for?
Codex definitely is for everyone, right? Like we want users to develop, to build things with Codex, and we of course want them to have the confidence of building things with Codex, right? So one of my favorite examples of Codex in the wild is our pull request review, right? Where Codex of course would look at the diff of all the changes that it has done, that you have made within the pull request, and it would contextualize it with the rest of the files in the repository. So you're not just bounded by whatever changes you've done, but by the overall context of the repository. And sometimes that it would flag issues which may not be caused, which may come up as a consequence of your pull request. And also, which are just some gotchas that you should know about. And especially for large code bases, this is really important, because this gives a developer the confidence that you can be sure that whatever you're merging is secure and it works the way it does. As an example of this, recently we released Codex 5.3 Spark, which is our fastest model, thanks to our partnership with Cerebras. And Codex by default writes the docs for itself, because why not? And so Codex wrote the docs, and it opened a pull request, and I was reviewing the pull request, and we have a lot of surfaces which developers would sort of interact with when it comes to the docs, right? So there would be, docs about IDE, docs about, the app, and so on and so forth. And this particular model, at the time that we launched it, was only launched for Pro subscribers. And for some reason, Codex Spark didn't really make that change. And so when I prompted it to sort of fix it, automatically the Codex review on the pull request flagged that I should also sort of make this node on the app docs, also on the CLI docs, just so that everyone is aware that this is how you use it, or these are the segments of user who should use it, right? And this is purely like the only reason why it was able to flag this was because it had the contextual knowledge of the rest of the repo and the rest of the docs.
Yeah, it's really nice to hear how complementary the two are, right?
Yeah.
So Codex comes up with a certain type of issues that are very kind of contextual over what's being built. It understands different things. And then Sonar is coming up with issues that are contextual as well, right? We're not just analyzing the code that's there. We've got aware of the whole repo, the whole build, everything that's been the thing. But they're different types of issues where they'll kind of foresee. And I think together the two really complement each other to give good security. I think, your point around developers could be all sorts of different people going forward, right? It's not quite the same skill set that is necessarily required. Really increases that need for that check and that tooling to make sure that everything is good. And obviously things like taint analysis, where injection attacks and things like that can be found, are some of the most critical ones. And our analyzers can go in and sort of deterministically follow the paths and make sure that all those paths are safe. And that's something that we invest a lot in, as well as kind of other issues like, things like null reference checks and stuff like that, which are super hard just to see if you're looking at a single file. But if you can follow the path all the way through the files, which our analyzers do, and understand all the different types that are in there. So, we use the artifacts from a build as part of our analysis, and that's our new advanced analysis service that's available in MCP is effectively doing that. It's joining up the code you've just written with the last build it's seen, and it's kind of together it can do a really deep analysis and find those issues, which thing. And I think together they find a good set of issues and keep us a bit safer in an increasingly risky world.
And I think that's the thing. It's interesting because it's not just about, is this particular piece of code good enough to go to production at this point? It's almost like an educational thing, both in terms of me as someone coming back into development, helping me understand some of the technology that perhaps I haven't touched before, but also making the agent smarter for the next time around. So I guess you get this virtuous cycle of where things get faster and faster and smarter, when the alternative is, if you don't have those checks, things can diverge and that can get exponentially worse over time. You mentioned how Codex is good as a docs writer. I wanted to touch on sub-agents. How do sub-agents, or maybe different personalities of agent, come into play when it comes to Codex?
Definitely. This is currently in experimental. So we recently added support for sub-agents, which effectively allow you to sort of parallelize whatever task you're doing with Codex, right? And so you can have like different personas for these agents. So one could be a test runner, one could be a reviewer, one could be someone who's responsible for writing docs, and one could be who's just polling the server for a response, right? And effectively what this allows Codex to do is to essentially spin up these agents as it thinks that an agent should be spawned and should do the task. And this helps you sort of achieve the same task in not only like a faster way, but also in a more secure way, because now you have like an agent which is effectively just focused on solving one task, right? And so I can actually see this play quite nicely with like Sonar MCP, wherein you can have one agent which is dedicated to the Sonar MCP and is like essentially just continuously polling Sonar MCP to check if there are any new issues with respect to what has been added into the workspace so far, and play quite nicely with the other agents, thereby like driving much more confidence in the.
I think we're going to see verification agents, interacting with the main engines, working as sub-agents, increasingly. And It doesn't have to just be the Sonar checks. It can be other checks as well that you put in your organization. I think that's, it's going to be something we're going to see emerge very quickly.
See, this is the thing. It feels like it's very much an evolving way of working, because we talked a little bit earlier, and you were saying in the Codex team, you're running agents for sometimes hours, sometimes even longer, unsupervised, and they're producing really, really solid results. How do you recommend people break up work into chunks? How do they know what the right size chunk is to attack and get the best possible results?
I don't think there's like a right answer to this, right? At the same time, like, I think you can use like the current tooling quite to your advantage in this case. For example, typically if I am embarking on a complex task, what I would do is switch Codex to plan mode, and then like ask Codex to sort of like think through what are the possible ways to sort of build this particular feature that I want to add, right? A concrete example of this would be when we created the docs MCP server for developers.openai.com, right? That was also one of my first projects at OpenAI, and I just gave Codex an open-ended task that I want to build an MCP server. How do I build it, right? And in an environment which I had no clue about, right? I'd just freshly gotten into OpenAI, didn't know how everything worked, but I wanted to get a good understanding of how the overall sort of code base is structured, right? And so then it went through, like, it gave me some suggestions that maybe I can use this framework, maybe I can use framework Y, maybe I can have like a standalone repository for the FCP server, or just have it as a microservice, or as part of our the main sort of developers docs server. And eventually we settled down on a plan, and then I asked Codex to create test cases first, just so that like it has something to verify its results. And this is also something that we've seen, that Codex excels when it has test cases to hill climb against, or like verify its work against. And like after some iteration, it just went on, like created a proof of concept, tested it, kept on like iterating on that, and after a couple hours we had a really nice docs MCP server ready, right? And of course then we went through like internal dog fooding and so on and so forth, and we uncovered some issues with that, and we fixed that and so on. But at the same time, like you can like use like these agents for planning your task quite well, and then once you have a nice plan, you can leave it up to the agent to either divide that into chunks, or use sub-agents, or use background processes to run certain things, and so on and so forth, as long as you're sure that whatever task you're embarking on can be verified that it is the way.
I think that's key, isn't it? And it goes back to what you said earlier on, depending on the risk profile of what you're building, you might want to let it loose for longer, or let it loose for shorter. And I think, if you've got something that's very critical, you've got that plan, which is fantastic, but you can tell it to stop at any point in that plan and do a review. You could do your deterministic checks at any point. And it's like any development, right? The earlier the feedback loop is, the faster that you find problems, the less there is to fix later. So the longer you let it go before the verification, the harder it's going to be for it to do things, the more it's got to rework, in a sense. And I think if you've got a very critical application, then putting in breaks quite often, and even if that's just deterministic verification using tools, or whether it's human verification, okay, is it doing what I asked it to do? And actually maybe even reviewing every line of code in some situations, right? Is this some high risk code that I really want to review carefully before we move on? I think that's going to be the key for enterprises, to be able to embrace that kind of flexibility. And experience, I think that's where experienced developers really come in as well. They know where the risk is. They know where we need to slow down and really check everything through. Where a junior developer might just kind of put the plan in and go, that looks great, and go for it and push the PR kind of thing.
Yeah.
So I think this is why we still need those experienced developers. And it's the same problems as we had with human developers. It's just coming at you faster now, right? It's like, it's less time actually writing the code and more time going, okay, let me stop and think, is this right? Can I move on to the next step? And I think that's going to be key in the workflows.
And I guess one of the great things about this is the feedback loop is so fast, so you can build up that intuition Even if it's me coming back into development, I can quite quickly get a sense of what isn't going to work, what is going to work, and you get that intuition for, yeah, it's time to run the static analysis now before we move on. One thing you mentioned about how you could use Codex to help you sort of understand the code base. We know that AI tools are amazing when it comes to a blank page or to a relatively young code base where you've got sort of one consistent best practice pattern. Can you talk a little bit about how you would recommend people get good results if they've got an older code base that perhaps has gone through sort of several levels of best practice? So maybe there are different examples spread everywhere.
Yeah, I mean, like I oftentimes would sort of deal with code bases which I haven't contributed to, right? And most of the times, like the way I would start it is by just spinning up Codex, opening that workspace, and then like ask it to sort of, walk me through like a particular functionality within that particular code base, right? So, and then I would ask questions, and most of the times I would ask like really stupid questions, because of course, like I don't want to make a fool of myself with the engineering team or like with everyone who's actually like building on that code base, right? And so I would ask like, okay, why are we doing this? And if I was to add like this functionality, how would that look like? And just, what were some of the design decisions? What were some of the, decisions for testing? How do you make sure that this is correct and not? And you can really go as far as possible with this, right? As someone who wears like multiple hats within the team, like this is quite important to sort of get an intuition of even like newer like features which are coming in really hot within Codex, just to get like a good understanding of it. Of course, there are also cases wherein I'm just like I even don't have like good understanding of how to even set up this particular code base to be able to sort of interact with it. In those cases, I would just also like ask Codex is like, if I were to set this up, what would be the steps, right? Walk me through those steps, and I would myself like execute those steps, or like ask Codex to go step by step and like execute it for me, just so that like I have a working playground to go around. And we see the same pattern like within teams at OpenAI as well. From like product designers trying to get an understanding of how the app functions, right, and how some of their designs can be integrated, to PMs who are looking at code bases, looking at linear logs and linear issues to see like how the progress is going, to cross-functional people like me who are essentially keeping track of like what's happening, where it's happening, and so on and so forth.
One of the things I love about agents is getting the agent to read the documentation for me. I've never enjoyed reading the documentation. But I think, I mean, it's really interesting with legacy applications. I mean, partly it's going to be down to whether there's good unit tests on it, right? And the agent can work relatively safely if it's well covered with unit tests. One of the things Sonar does is, and a lot of people really use it for, is to check that the code coverage is good whenever people check in code. And with an agent, it's pretty easy to say, okay, increase the code coverage to this and create the test. But it's one of those where the human needs to be checking that actually that is the behavior. If you're retrofitting tests, is that the behavior I actually expect or not, kind of thing? Because the agent may just create tests that it'll know will pass based on the current code. And I think this is going to be a bit of an art as well of working on legacy systems. But we've probably got to relearn with an agent. But a lot of the old principles still apply, and making sure that you're covering that old code base with tests well, and so that whenever you change something, you're not going to get something unexpected, because you generally haven't got super maintainable code that's easy to understand.
Right. And I think like, historically, if you sort of see like what I've seen is that a lot of people would often sort of, discount testing or discount like these sort of processes as being slow, right? And like adding to the overhead of like developing faster. But as these agents are becoming faster, for example, 5.3 Codex is 60% faster on the basis of number of tokens it produces and so on, as compared to 5.2 Codex, which means that you can do the same task with the same confidence but much faster, right? this sort of excuse of like, running these test cases or like, running these sort of checks and like balances, kind of disappears, right? Because like now you are not the one who has to wait for your agent to sort of like, figure out the like what kind of tests it has to run, what kind of files it has to run, and like the overhead sort of like decreases considerably.
Yeah, yeah. I mean, I love the way agents are really good at TDD. They can do test first really nicely, but it's still up to that developer to actually run through and make sure the tests that are being created are actually what's expected. But they're well-written tests that are easy to understand, and you can verify that relatively quickly, and then you've created that safe environment to then do the fast coding with.
So we talked about a lot of ways of working. Let's get into some concrete examples. So Tom, do you have some examples of how a real customer is working in this way in production?
Sure, yeah. So, I mean, I think our big enterprise customers, they're still really working out. This world is changing so fast, and they're generally a little bit slower to move, but I've seen people moving really quickly, and the kind of way they're doing that is experimenting. So even large financials, they're finding teams that can work with these tools, and they're giving them the freedom to work. I think doing that, the first problem they've got for those teams to solve is how do we code with the same standard that our company has at the moment, right? And so they have to start building in those verification strategies into the tools. Now, they're probably going to start on less critical applications, right? Not the most mission critical trading applications just yet. But you can learn on lower risk applications, but still apply the same standards as you would do on a mission critical application to build that infrastructure. And what VB was saying about, the tooling and creating the skills and things like that, they can then be used anywhere across the application. So I think what we're seeing is people experimenting. They're kind of starting to build the infrastructure around that and then growing that out to more teams as they see success and as they become confident that they can do this safely and securely. I think that's the critical thing for the enterprise.
Great. And I mean, you talked about this with the difference between 5.2 and 5.3, the pace of change and the capability of the agents, it's increasing incredibly fast, and it's changing wildly. So something that you might consider impossible today, in a week's time, is very, very doable. How do you recommend companies keep an eye on this and really understand what the art of the possible is?
I'm a firm believer of just like testing things, right? So I feel like as long as you have a safe sandbox, and you have the ability to make sure that your agent doesn't mess up, right? I think like the first step should be to just download, for example, Codex, right? And just give it a task that you want to do, and just try and see like how it tries to solve the task. In a lot of cases, what might be beneficial is to create an agents.md file. Like agents.md file is like, think of it as like the soul of your project, right? So you can have here are like certain folders, this is what the folder does, and here are like every time you do a task, run these tests, and here are some rules for whatever it is that you want to do, and for certain specific tasks and so on. And if you're using tools like Codex, you can just create this agents.md with Codex itself, right? And like every so often, for example, on our developers website, what we do is we have like the skill. Its task is to make sure that none of the typos, none of the like the language of the docs and so on are uniform across, right? And this was a suggestion which came from Codex, and then Codex helped build this into a skill, and then of course like we iterated a bit, and this is now run on like each and every change, right? And so like the best thing to do is to sort of like try and pick up such use cases for either a new project or an existing project, and just like work with the agent to figure out what are the boundaries of what is possible right now, right? And this is something which I do with like every new model as well. Like back in December, we had 5.2 and 5.2 Codex, and there were certain tasks which were possible back then and certain tasks which were not possible. But at the same time today, like we have 5.3 Codex, we have 5.3 Codex Spark, which is our faster model, and each of these like unlocks like certain new tasks, and also at the same time makes previous tasks faster. And like it's really like you just like iterate with these models, try and give them your problem, try and give them the ability to verify what they're building, and then just like riff off of that.
Yeah, I think that's really important. I mean, the agents.md is the entry point in. I think, to start with, let's think about the project you're working on. What are the standards you want to set for that project? And they're probably partly organizational, they're partly contextual to that project. Put those into the agents.md to start. And the agent will do a pretty good job of following those standards from the outset, right from the beginning. But then you've got to remember that that's not necessarily deterministic, that if it's not using tools, it will do its best to follow those standards, but you can't guarantee that it will. So I think the next step is then to start thinking, okay, how can we enforce those standards in a deterministic way? And therefore by using tools, you can then start installing MCP using CLIs. So we're sort of seeing a little bit of a move from MCP to CLIs because it can be a little bit more deterministic. And we're building that Sonar now. But at the moment, there's the Sonar MCP server that you can use today. It will already do those checks. You can already check the SonyCube status. So you can quickly build your standard process that the developers have been using potentially for years straight into the agent process and make that efficient from the outset. And then as it just build on sophistication in the same way as we've always done with CI pipelines, right? They generally start off really simple, and over time you add more checks, you add more controls, and they get more sophisticated. Hopefully don't get too slow, and they're still fast, and keep the team going. And it's just the same thing, but we're just now building that into the agent workflow.
And I think you can also do it in sort of different cadences as well. And correct me if I'm wrong, you can have sort of like one-off or like recurring sort of jobs which are essentially looking at your code base outside of PRs, outside of all the commits and so on. Just like a cron job, for example, we have this ability within the Codex app that you can set up automations. I can see this quite nicely play with the Sonar MCP, wherein like every day at, let's say, 11:59 p.m. Codex wakes up and runs the Sonar MCP through like all that has been added in the last one day, and verify it against all the logic that the team has defined, and try and sort of like think outside the box and like find what could be improved, what should be kept as is, and so on and so forth, right? And you can truly use this in different ways as well. Like if, let's say, the Sonar MCP finds an issue, you can ask, in this case, Codex to open a proactive pull request. And then next day when Tom wakes up, Tom can review these pull requests. And I feel like, this way you have the confidence that even if, let's say, by 1%, something is missed by these agents, you are able to still sort of, solve for that 1% use case.
Yeah. I mean, some things we can build super fast and you can get immediate feedback within a second. We can do most of our analysis like that. Yeah. But some things are longer running and you might just want to run them nightly. That's absolutely fine. Just like we always did with sort of long running tests and things like that, right? So yeah, it's very much the same principles. Think about, is this something that I can check fast? In which case you might want to do it like really regularly within the agent workflow, or is it something we just do in a PR, or is it something I might do nightly and do a really long running check? And there's so much possibilities, and the fact you don't need a human there to sit and watch it is kind of opens up all sorts of possibilities. And I think we can get to a point where we have a higher coding standard with agents than we do with humans. I think at the moment we're talking about, okay, how do we get to the same? But I think we'll soon be thinking, okay, we've now got these capabilities, we can go further than we ever did on quality, which will be good for software in general.
100%.
Yeah, absolutely. It does seem like there are so many different levers you could pull on, ways of working with AI, and I think it's great that Codex can be part of that, but also you can go to Codex and say, hey, what should I be doing now? What other checks could I have in place? And your idea about the cron job running nightly and being able to build that out through Codex is hugely powerful. So as we move towards the last question, then we're just getting close to some really, really concrete things for people to do. If we think about right now, so for people who are watching and they're excited about getting their teams going, getting their whole organizations working in this manner, what are some concrete first 1, 2, 3 steps they should be jumping on right now?
Well, first aid, obviously, agent running in a team that's relatively low risk. I think we covered that. Then MCP is your friend, right? So work out what MCPs you need to be working with that can do the checks that the agent can interact with to actually make it capable. An agent without other tools is really limited. And I think in your organization, you're going to have various things that you need. You know it needs to interact with, and they're generally available in MCP. You'd get that going straight away. Start relatively simple, and actually agents.md is a super easy way to start saying, these are the standards I want you to code at, and then start tooling, adding the tooling into that process and just slowly increasing in sophistication. And then once you get to a certain level of sophistication, you'll feel confident to go out to more kind of critical applications.
Yeah, and I think, just to sort of add on, I would say just start simple, right? No task is a small task for an agent, right? Even if it's just fix a typo in readme.md, just try and delegate it to an agent. And the worst things that's going to happen is it opens a pull request, right? And you can always close it, or just as long as you know that whatever it is, whatever playground you've given to the agent is secure enough, just try and start with simple tasks that you can delegate, and then work your way from there, right? Layer in the MCPs, the skills, the tooling, web search, all the things that you think is going to help the agent get the context, the core knowledge of your company, your organization principles, directives, and so on. And just work piece by piece, remove what doesn't work, and add what works, and so on.
I think it's important to have the right expectations for your teams adopting these tools as well. I mean, if your expectation is they're going to have a 20x productivity improvement overnight, they're probably not putting these checks in place, and you're probably taking a lot of risks. I think, if people are, the team is building the tooling, working on the process correctly, initially they're probably not going to be much faster. And that won't be kind of give you instant satisfaction, but that they are investing in what's the future of software development, and over time that will start paying off, and you'll quickly see the performance improvements in the teams.
Brilliant. I think that rounds it up really nicely. It's the agents and everything that comes around that. It becomes this supercharged engine of your racing car, and then the deterministic checking is the thing that keeps you on the road. And with that, thank you very much, gentlemen. That was fascinating.
Thank you for having me.
Thanks, John. Thanks, Vivek.